Is that what we got visually when we looked at the graph?
Yeah.
Yes. So now we have used two methods, both visually and mathematically. Okay, Shamar, please pick your head up. We have found two ways, both visually and mathematically, to find our x-intercepts. Okay. Real quick, I used some different names to talk about our x-intercepts last class. Does anyone remember what else I called them? If there's any other names we can call them?
Zero.
Say that nice and loud and proud.
Zero.
Zeros. Roots.
Solutions.
And solutions. Someone's looking at the common board. Look at that. All right, so there is the next box underneath where we just solved. It asks you, what are three other names for our x-intercepts? We can use them interchangeably. Zeros, solutions, and roots. Go ahead and jot those down now so that we can use them interchangeably. We should all be using that vocabulary to talk about these. Okay? Okay, that was all to get us oriented to the quadratic formula. Okay? So when you're done writing down our interchangeable names, we're going to go ahead to that next page and let's talk quadratic formula. Okay? First things first. If ax squared plus bx plus c equals 0, what do we call this? We've seen this before. It's a polynomial. What kind of form is that in?
Trinomial.
It's a trinomial. What format is this in? Standard form. Okay, good. So if this is in standard form, if we're given an equation in standard form, okay? Let me ask you this. What do we call A and B? What do we call numbers that are in front of variables?
Coefficients.
Coefficients. Good, James. We're going to be looking at our coefficients today to help us figure out the quadratic formula. So, once we have an equation given in standard form, we use the coefficients to fill in our quadratic formula. This is big, okay? And it looks like a lot, but we got this. So what I want you to do is in that box, we have x equals our numerator and then our denominator. I gave you your division line. Go ahead and write the formula down. We're going to become really familiar with this formula, okay? This formula says, we read it as so, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay? We're going to get really used to this formula. Okay? Let's make sure we have that down. That is so important. So important. So we have this formula, but what does that mean? What is that going to tell us? Why do we have all these letters and numbers and all of this? Okay? Let's talk about it, right? So the next thing you have in your paper, something that says the discriminant. Okay? If you notice, on your paper I told you the discriminant is b squared minus 4 times a times c. What part of the quadratic formula does that come from?
No.
It's under what? What do we call that? The radical sign. It's what's underneath that radical. That's what we call our discriminant. Okay? So, there's a lot of stuff up here, but what I want us to first see is that if we are looking at that first box, okay? Look at that first box on your table. You have a equals 1, b equals negative 6, c equals 7. We know through order of operations and through substitution how we could solve the discriminant, right? If we have b squared minus 4 times a times c, how do you think we're going to set up this first box? Plug it in. We're going to use substitution. So can someone raise their hand and tell me what that would look like for the first box? Frank, help.
For b squared,
Mm-hmm.
negative 6
Good,
Negative 6 squared.
good,
Minus
uh-huh.
8. I say 8.
Minus
1.
one.
Minus
Minus 4.
Minus 4,
four.
good.
Somewhere.
Go ahead, Brenda, keep going.
times 1 times
Uh-huh.
7. Times 7.
Times 7, good. Now,
You got it?
help me solve this out. Everyone on your papers, go ahead and solve this out. What I want you to do,
You got
solve those 3 boxes just like this, using substitution.
Oh, I see it.
You see? Okay, I want you to solve in these 3 boxes right under the discriminant, using substitution from the numbers, the values that they give you. I want to know what the discriminant equals in each of those 3 boxes. Remember order of operations. No, what does order of operations tell us to do?
You saw?
We want to simplify all of this.
So you want to put this.
But what does the order of operations tell us we need to do first? Good, admin.
Minus 6x.
Good. So let's see it. Let's solve each of those 3 boxes. I want to know what those all equal.
Right? 6 squared minus 6 squared. Any number to the second power is possible.
I want you to solve whatever on the board. You saw how Frankel helped me substitute. I want to find the discriminant. Here's like our equation.
4
Okay,
times
using
7.
these values.
4 times 7 is equal
Yes.
what? 4 times 7 is
Nope.
equal what?
What do our order of operations
You
tell us to do?
multiply 4 times 7, 4 times 1 times 7. You are calculating.
We work left to right. Just like we read, right? But what do my order of operations tell us to do first?
No, equal what? You have to find it.
Excellent.
36 minus 28.
So, let's simplify. And
Okay,
our
what
exponents
to
and
do
then
is
move left to right.
B2 minus 4AC.
Mhm.
B is negative 6, negative 6 squared minus 4. A is equal what? 1. C is equal what? 7. Minus 6
Okay,
squared.
now let's
Minus
move left
6
to
squared,
right.
how much is that?
So
Because you put
36
this
minus,
first.
now we need to do all our
Minus
multiplication
6
before we
squared.
even do our subtraction. So let's ask ourselves, what's 4 times 1?
Minus 6.
And what's 4 times 7?
Equal.
What's 4 times 1?
36.
We move left to right. What's 4 times 1?
Minus 4 times 1 times 7. Go 4 times 4 times
Nope, we move left to right. It's all being multiplied. So it's 4
7
times 1
equal 28.
and 4 times 7.
36 minus 28 is equal what?
Can't drop. 4 times 1 is 4 and 4 times 7 is?
Minus.
Got it?
You multiply
So remember,
28, put 28 there.
and then go ahead and solve those.
And then you say 36
Okay,
minus
make sure you're solving all 3 boxes.
36 minus 28.
I got it.
Let's think about our signs. What happens when you do a negative times a negative?
You tell the same thing.
Okay?
Yep.
Do A, do the number 2, number 3. A. That's the number 2. B2. Do number, and do number 3.
Is this gonna be
Do this and this. Go do it. Do it. Do, come on, come on. You can do that.
We're not gonna do it in here.
You don't substitute it. What is it?
Not happening.
Yeah, it's 6 again. Minus 4. What is it?
Okay, you're right.
1 again.
We're not using this
Oh,
number.
you said you.
We're just using the discriminant.
Oh, yeah, 1.
So,
What
we're
is
using
C?
just
What
like
is C?
Frank helped
You
us
put
set
that
up.
there. And then you multiply this square. Find it and multiply 4 times 1. And I
Okay.
say subtract. Let's say multiply. Go, do it. Do it. Do it.
Alright. For this first box, I would like you to
Perfect.
solve all
Do it
3.
Do it one.
If I have negative 6 squared, a negative times a negative is a positive. So I have 36. We have to do exponents first. Minus 4 times 1 times 7. Order of operations tells us we need to handle our multiplication from left to right next. 36 minus 4 times 1 is 4. 4 times 7, 28. Now we can simplify. 36 minus 28 is 8.
It's a negative 8.
Okay?
It's a negative 8.
Now, please go ahead and complete the next 2 boxes, guys.
Got it? Finish first, finish.
Keep the 4. The 4 is a constant. So once again, we have b squared minus 4 times a times c. And they provided you with the values
Again.
of a, b, and c.
You need help?
Can I have Tevin? Can you come and solve this? Jake, do you wanna come and do this one for me?
Nah, let me do it, Miss Liz.
Jake, come and do
Oh
it.
my God. You didn't even let me.
And that, get up on the floor, I'll let Frank, I'll come and put them in that. Jay, you don't need your backpack, sweetie.
A
You're
is
not
equal
going
1,
far.
A is equal
Where you get the
1,
four from?
A is equal 1, C is equal 1, 9. Perfect, perfect, perfect. Look at this. Perfect. Good.
Sir.
A is equal to
I'm
0,
still
0 is equal to 0, and this is
Mr.
equal to 0.
Gutierrez.
The same thing.
Good.
Good.
Got it.
Do this one now.
Alright, Frank, how you're up?
Okay.
Alright, hold on. We coming right now.
Okay, look at this.
No.
Square, let me see square.
I got you like the whole problem on that.
Look at this. Square. Minus
You heard lunch shit. And before.
4 times 1 times
You did my.
Yo, James, shut up.
You wait for
Doing it wrong.
What about our order of operations? Where are you going? Where are you going? Left to right, order left to right, before you can do any
Hey,
multiplication, what do you need to
finish,
tackle?
do the word. Good.
What do you need to tackle before you can do any of the
Perfect, do
multiplication?
the one, the last one.
What are your order of operations?
Good, good. You was a pretty good student. You was a pretty
What
good
did Shane do
student.
first over here? What did we do first over here? Before we tackled any of
He
the
was,
multiplication?
hold on. Hold on, he was a pretty good student.
Keep going, we can do it right now. What do we need to do first? Let's look over here, what did Shane do first? What did I do first? According to our order of operations. Do you start reading a sentence in the middle of the middle of the page? Where do you start? Which is on which side, the left or the right? Okay, so we're reading from left to right, according to order of operations, what do we need to do first? So what, let's go for that. Good. We have to go in the order of operations.
Good.
They're right next to each other.
Perfect. Read. You it is. Take it.
Alright. You have to go in the order, if you go backwards, it will mess it up. Okay? Alright. Okay. So, we're up here. We've now got these different answers. What does that mean? Well, when we look right below, if the discriminant, so what I want you to write, if the discriminant, which is b squared minus 4ac, is greater than 0, how many solutions do you have? Two. If the discriminant, b squared minus 4 times a times c, is equal to 0, how many solutions do we have? One. B squared minus 4ac is less than 0, how many solutions do we have? No solutions. Okay, so here is an example. Okay, what that looks like. If we have 2 solutions, what does that mean?
That.
You have to solve.
What do our solutions mean when we're looking at parabolas, when we're looking at quadratic functions?
That we got X.
We have 2 x what?
2x intercepts.
We have 2 x-intercepts. So when our discriminant is greater than 0, we have two solutions. We have two x-intercepts. Our graph crosses the x-axis,